For more than 7 decades, the most powerful air force on the planet dominated the skies under a simple and indisputable premise. Its fighter jets were always a generation ahead of any rival. However, the race to deploy 6th-generation military aircraft has triggered deep alarm in the Pentagon. The real military concern stems not from a fear of the technology itself, but from a crushing combination of financial pressure, industrial paralysis, and the frenetic advance of rival powers that threaten to wrest away its strategic air superiority. The next-generation air dominance program was conceived to replace the most advanced platforms in the current inventory and ensure atmospheric control for decades to come. However, military commanders are watching with genuine concern as historical assumptions about the speed of development and industrial capacity are being shattered. The technological advantage accumulated since World War II risks evaporating if competing powers manage to bring their own 6th-generation platforms into service simultaneously or even earlier. If you're passionate about analyzing the geopolitics of defense, the secrets of top-secret military programs, and the race for control of the skies of the future, subscribe to the channel now and turn on notifications so you don't miss any episodes. The first major red flag for American strategists is the pace of development and the speed of industrial iteration of Chinese military aviation. Historically, it takes the U.S. defense industry between 15 and 20 years to design, test, certify, and formally incorporate a new fighter jet into its operational squadrons. The clearest example of this bureaucratic and technical slowness was the development of the 5th-generation light fighter, a project that took more than 2 decades to reach operational maturity after suffering countless delays and cost overruns. In a stark contrast to military intelligence analysts, the Asian giant's aerospace industry has demonstrated a substantially faster and more flexible capacity for iteration. While the U.S. 6th-generation program faces constant cost revisions, parliamentary debates, and modifications to its required specifications, Asian shipyards and research institutes are advancing prototype development through significantly shorter testing cycles. This ability of the rival industry to move from the drawing board to test flight in short timeframes shatters the traditional hegemony of the Western military-industrial complex. If Beijing's armed forces manage to deploy an operational 6th-generation fleet within the same time frame as Washington, the air superiority gap that has protected Western strategic interests for generations will vanish completely. The real danger lies not only in the technology of the new aircraft, but also in the terrifying speed at which the rival industry is able to build the future. Alongside the terrifying production speed of rival powers, the second major obstacle keeping military commanders on edge is a purely financial barrier. The next-generation air dominance program doesn't envision the manufacture of a single aircraft, but rather the deployment of a complex family of interconnected systems. This combat network will be spearheaded by a highly advanced manned fighter jet acting as a mothership, coordinating in real time the tactical decisions of an escort of autonomous support drones. However, the projected costs for building this primary manned fighter have reached figures that challenge the government's own economic viability. Internal estimates from defense analysts place the value of each of these 6th-generation aircraft between $200 and $300 million per unit. To put that figure into perspective, the price of this new aircraft would triple the manufacturing cost of the most advanced 5th-generation fighters currently in mass production. This disproportionate escalation in engineering costs presents the Air Force with an insurmountable dilemma when planning its annual budgets. With increasingly tight financial constraints and soaring inflation in microelectronic components, purchasing a large number of these aircraft is simply impossible. The most realistic projections suggest that the armed forces will only be able to acquire a very limited number of units, creating a small elite fleet that will barely be sufficient to cover the most critical fronts. The fundamental problem with relying on a small fleet of perfect aircraft lies in the harsh reality of modern high-intensity warfare. In a scenario of prolonged open warfare against a power of similar military capability, operational losses, attrition of aircraft structures, and maintenance due to combat damage are inevitable. A small number of aircraft, however sophisticated and stealthy they may be, cannot be divided to cover multiple theaters of operations simultaneously or withstand a prolonged battle of attrition. If the enemy possesses the capability to manufacture acceptably advanced aircraft at a third of the cost and in massive quantities, the advantage of absolute quality over quantity is completely negated. Military strategists understand that an air force composed of a few dozen flawless aircraft risks running out of operational platforms after the first few weeks of a large-scale engagement. The fear at the highest levels is not only the price of the aircraft, but the terrifying prospect of building a technological marvel so costly that it cannot afford to lose it in combat. Adding to the dilemma of budget and industrial speed is an insurmountable physical limitation that constrains any battle plan on the Asian map: the tyranny of distances in the geographical space of the Pacific Ocean. Current strategic fighter jets were designed for European or Middle Eastern theaters of operations, where the distances between launch bases and combat zones are relatively short. These fifth-generation platforms have an internal combat radius that ranges only between 470 and 600 nautical miles without relying on external fuel tanks. In the vast expanse of the Indo-Pacific Ocean, geographical reality shatters traditional planning. The distances between strategic military bases on distant islands and likely coastal conflict zones are measured in thousands of kilometers of open water. If the sixth-generation platform fails to solve the complex equation of adaptive variable cycle engines capable of modifying their internal airflow to deliver enormous thrust during combat and minimal fuel consumption in cruise flight, the aircraft will be unable to reach the operational area and return under its own power. To address this lack of range without sacrificing the sleek shapes that provide radar stealth, traditional aviation is forced to rely on enormous aerial refueling tankers. However, using these heavy, modified commercial support aircraft represents the weakest and most vulnerable point in the entire combat chain. A tanker is a slow, gigantic platform with no electromagnetic cloaking capabilities, making it a prime and easy target for any defensive network. Rival powers have deliberately designed a new family of ultra-long-range air-to-air missiles capable of traveling several hundred kilometers at hypersonic speeds. The enemy's military doctrine does not seek to engage the Vanguard stealth fighters directly, but rather to evade them in order to destroy the heavy tanker aircraft flying in the rear. The moment an enemy missile destroys a fuel source in the middle of the ocean, all the advanced fighter jets that depend on that tanker are doomed to burn out in the air and crash into the sea before they can return to their bases. This systemic vulnerability is generating real panic among commanders responsible for strategic planning. If the sixth generation of military aircraft cannot autonomously double the operational range of its engines while maintaining its stealth profile, the Air Force will find itself with marvelous aircraft that cannot take off without risking being stranded in the middle of the ocean. The battle for the skies of the future will not be won on the front lines, but rather by the ability to fly thousands of kilometers without leaving a fuel-dependent trail in the rear. The final major factor keeping military strategists on edge is the radical transformation in the very concept of air combat. The sixth generation completely redefines the rules of the game in the atmosphere, leaving behind the era of duels between agile pilots and ushering in the era of information supremacy. In the theater of operations of the future, victory will not go to the aircraft that performs the tightest turns at close range, but to the platform that functions as a supreme real-time data processing center. In this new integrated network doctrine, the manned aircraft acts as the brain of a cyber swarm. Its primary mission is to coordinate distributed sensors, assign targets to its accompanying drones, and process terabytes of information in fractions of a second to make tactical decisions before the adversary. However, this absolute reliance on digitization creates a terrifying systemic vulnerability. The entire operational architecture depends on the uninterrupted stability of its jam-shielded broadband communication links. If the adversary manages to launch a massive electronic warfare attack that disrupts or degrades the transmission channels between the mothership and its robotic companions, the entire defensive network disconnects in an instant. Losing their connection to the main processing center, the autonomous drones become disoriented in the air, or are forced to activate emergency withdrawal protocols. The main platform suddenly loses its advanced defensive shield, leaving it exposed and alone against swarms of enemy missiles and aircraft. This digital fragility demonstrates that the greatest danger to sixth-generation aircraft lies not in the power of their engines or the precision of their weapons, but in the vulnerability of their integration algorithms under operational stress. A flaw in the software architecture or a breach in cybersecurity can invalidate years of development and multi-billion-dollar investments. The Air Force that dominates the skies of tomorrow will not simply be the one with the stealthiest fuselage, but the one that can keep its data network secure in the midst of the worst cyberstorm. The current race for air superiority has entered a critical phase where the margin for error for Western powers is virtually nil. Confronting the breakneck speed of rival nations' industrial production, the astronomical unit costs, the vast ocean distances, and the latent vulnerability of cyber warfare demands a profound and urgent transformation in how military power is designed and built. This transition allows no hesitation, as conventional technological superiority is no longer a sufficient guarantee of victory in a modern war scenario. Ultimately, the power that manages to master the delicate balance between the integration of artificial intelligence, long-range strategic reach, and the economic viability necessary to sustain an operational fleet will be the one that maintains undisputed control of the skies for the rest of the century. If you were shocked to discover the true dilemmas and fears facing combat aviation in its race towards the sixth generation, subscribe to the channel immediately, like this content, and share it with your friends who are passionate about military technology so we can continue exploring the secrets of the future of defense together.